Alright, welcome to our continuation of 1.7 transformations of functions. In our last video, we were looking at, or we did look at horizontal and vertical shifts. We looked at reflections across the x and the y-axis, and then we got into horizontal and vertical stretching. We played around with, last time, a vertical stretch in example 4. And I said in this video we would continue with example 4. So let me quick pull up what we had, and then we'll move on to B. Alright, so B, we're going to look at g of x, and it's going to equal 1/3 of the absolute value of x. So if in A, 3 times the absolute value of x, that was a vertical stretch, with this 1/3 being between 0 and 1. In G, we're now going to have a vertical shrink. Some books also call that a vertical compression. What that means is each of our original points from f of x are going to become a third, or the y value will be a third of what it originally was. So we'll still have 0, 0 be at the origin, but now instead of 1, 1, we're going to have 1, 1/3. And that's a little harder to figure out where exactly it is. So instead of guesstimating where that is, I'm going to go straight to 3, because I know 3, 3 is going to switch to 3, 1. We're going to divide 3 by 1. And then at 6, we're going to go to 2. And then we're going to do the same thing. And at negative 3, we're going to go to 1. And at negative 6, we're going to go to 2. So there's a vertical shrinking. In a way, you could think of it like an elephant or something really heavy sat on the original function and compressed it, pushed it down. We've now got in blue our vertical stretch, and in red our vertical compression, or vertical shrinking, as our book says. And in gray is our parent function. Let's look at one last example. In example 5, we're going to look at our parent function being f of x equal to 2 minus x cubed. And we're going to graph, or compare the graphs, of A being g of x is equal to f of 2 times x. And then in B, we're going to look at h of x being f of half of x, and how those affect the graph. So first I'm going to pop up what the graph of our parent function would look like. So here's my parent function. In blue, what we are looking at for A, this 2, that's inside f. What that means is we're going to take our original function and we're going to replace x with 2x. So we're going to do that. We're going to have 2 minus, replace x with 2x, and cube it. And remember from Algebra 1, long time ago, that properties of exponents say we can write 2x here in parentheses to the power of 3 as 2 to the 3 and x to the 3. And if you remember, 2 to the 3, that's 8. So we can rewrite this as 2 minus 8. X to the 3 we can just leave as x to the 3. So now let's graph our points again. If we take 0 and we put it in to our equation, we're going to still have our original point when x is 0. But now if we put 1 in, 1 cubed times 8, and then subtract that from 2, that's going to be 2 minus 8, which is 6. So this original point that was at 1, 1, now is going to go to 1, negative 6. And our point that was originally, if we replace x with negative 1, multiply it by 8, and then subtract all of that from 2, we're going to get 2 plus 8, which is 10. That's not even on my screen, but roughly what's going to happen... No, I did not do that very well. Let me erase and try to do that a little better. Alright, let's try that again. My graph is going to look roughly, this isn't as perfect as it could be, but it's going to look roughly like this. It's kind of like we took, it's almost like you take someone's face and you squeeze it between your hands. So that 2 in A, what's happening is that is a horizontal shrink, or in some cases they call it a horizontal compression. So let's try B next, and we're going to do B in red. Alright, so what we're doing is we're going to take, excuse me, Mr. Howard, I still had my eraser on. We are going to take our original function and we're going to replace the x's with 1/2 x. So we're going to have 2 minus 1/2 x cubed. And just like the last one, we can go 1/2 cubed and x cubed. But again, remember, recall from your middle school math classes, 1/2 cubed is 1 cubed over 2 cubed. So our function's now turning into 2 minus 1/8 x cubed. So from our original function, or let's just take some values and plug it in, I'm going to erase this little bit of work I have so I can have some extra space. So we can figure out what these new points are. If we use 0 again, 0 cubed, 0 times 1/8, 0, we're still going to be at 2. What's going to happen now is if we put 1 in, 1 cubed is 1. 1 times 1/8 is 1/8, and if we subtract that from 2, we're going to get 1 7/8. So almost 1, 2. And then if we replace that x with a negative 1, we're going to have 2 minus 1/8 times negative 1. So we're going to really have 2 plus 1/8. So our negative 1 is going to go to 2 1/8. And then my dot there is not perfect. It's close. And we can keep going, plugging more numbers in. And I think we should. Let's try, I think we should try 2. Let's put 2 in. I'm going to erase what I have just so I have a little bit more room. We're going to try 2 and negative 2 for x. See where those go. So if we do 2, we're going to get 2 minus an eighth times 2 cubed. 2 cubed is 8, and an eighth of 8 is 1, so we're going to get 2 minus 1, and that's just 1. So at x is equal to 2, y is going to be 1. If we try negative 2, 2 minus 1/8 times negative 2 cubed. Negative 2 cubed is negative 8 times 1/8, and subtract that from 2. So we're going to end up here with 2 plus 1, which is 3. So at negative 2, we're going to go and put a dot at 3. So what's happening here in red for our h of x is we're taking and we are horizontally stretching. It's like if you were to take some slime and stretch your arms all the way out as far as they could go. That's what we're essentially doing to the graph here. And that actually wraps up all the information we need to know from lesson 1.7 in our book. We will look at lesson 1.8 in our next video. Catch you later. Oh, and also, with your check for this video, I'm going to just put one question, and the answer to it's going to be, I don't know, blue marker. So I'm going to, in your check, just say what is the word I said at the end. If you put blue marker, you will get all the points. Bye.